Okay. All right, so 3A and 3B we rewrote. 3A had an outside. They all have outsides. 3A had two inside layers, or sorry, three inside layers. B had only two inside layers. Okay? That's the hardest part about doing the chain rule. Once you can identify what the outside and then the insides are, now we're just going to find derivative. Next thing we're going to do, 4A is actually find the derivative of 3A. Okay? This is kind of a roadmap. What's the first thing we're going to do? We're going to find the derivative of the outside. Something to the third power. That's just power rule, right? Move the 3 to the front, subtract a power. And the next thing is we're going to find the derivative of sine. And then we're going to find the derivative of something to the 1/2 power. And then the last thing we're going to do is find the derivative of 4x plus 1. Okay? So I'm going to use that as a roadmap. Okay? So I just rewrote it. The root is only for 4x plus 1. It's not for the whole thing. So the only thing that gets a 1/3 power is 4x plus 1. The whole thing is to the third power, is cubed. So that's why I put cube there. Okay? Okay, so so now let's do derivative.
How's it being cubed?
What's that? Say it again?
How's it being cubed?
Because the little 3 there.
But doesn't that mean the whole thing's being multiplied by 3, or to the third power?
Mm-hmm. That's why the whole thing, you see the whole thing, is to the third power.
Okay, so then how do we get cubed?
Mm-hmm.
Okay, it's not like the 3 square root.
So it's going to be, so another way of saying this is I could rewrite this 3 times. Right, that's another way of saying that, yeah.
But isn't that a square root?
Oh, sorry, yeah, you're right. It's not a third root, it's a square root. That's what you're talking about. Okay, that, yeah. Yeah, no, I was looking at a completely different thing. But you're right. No, it's a square root. Yeah, that's important, definitely. Did I put it square root? I did put square root up here. I just put third root. Okay. Okay. So what we said was the outside layer was the cubed part, the cubed. So the first thing I'm going to do is I'm going to take the derivative of the outside part. Not even worried about the inside right now. The inside is meaningless to me because I'm not there yet. So if I want to find the derivative of something to the third power, I would move the 3 to the front and subtract a power. That's all I would do. F prime of x equals, move the 3 to the front, change the power to a 2. What do I do with the inside stuff I haven't done? Rewrite it. Just rewrite it, yeah. Rewrite it exactly where it is. So sine of 4x plus 1 to the 1/2 power. And then I need a chain. Chain means multiplication. Okay.
Sine of something?
The next layer was sine of something. So now I got to figure out the derivative of sine of anything.
Cosine?
Cosine. It's just cosine, right? Okay. So that was the second layer, right? So it's going to be cosine of what? Everything rewritten. So now I'm just focused on the inside. The 3 and the 2 power, I'm done with. That I'm not going to touch anymore. So it's 4x plus 1 to the 1/2 power. Chain. Okay. Next thing, the next layer we said was something to the 1/2 power. Something to the 1/2 power. So over here, I'm going to go focus on something to the 1/2 power. Again, I could care less on what is inside the parentheses. I just want something to the 1/2 power. Okay? So something to the 1/2 power means I would move 1/2 to the front, rewrite whatever was inside the parentheses, and subtract a whole power. Chain. Okay? I got one more layer. The last layer was 4x plus 1.
Which is 4.
The derivative of 4x plus 1 is just 4. So the last link in the chain is just going to be times 4. If you can get to this spot, you're good. The next thing I'm going to do is clean it up. That's not calculus. That's just multiplying things. And so if you can get to this spot, that's where your goal should be. Okay? So how do I clean it up? How do I simplify? How do I do those things? Well, I have 3 is a monomial, 1/2 is a monomial, 4 is a monomial. Those guys are all monomials, so I can multiply them together because it's one big multiplication problem. I have this guy times this guy times this guy times that guy. It's a one big multiplication problem. So I can multiply 3 times 1/2 times 4. 6. 3 times 4 is 12. 1/2 is 6. Okay, then I cross these out just to show that I've done it. And then I'm going to write what I have left that I haven't crossed out. Okay, so I have a sine squared, 4x plus 1 to the 1/2 power. And then I have a cosine 4x plus 1 to the 1/2 power. And then I have a 4x plus 1 to the negative 1/2 power. All that's left is anything negative, move, put roots back in. It started with a root, right? It started with the square root, so I want to put roots back in. Anytime you start with a root, put it back in. So anywhere I see a 1/2 power, I'm going to give it back its root. So it's going to be 6 times sine squared. I'm going to put the power back there because that's where they had it to begin with, times cosine 4x plus 1. And then this guy is going to come to the bottom because it's got a negative exponent. 4x plus 1 square root. And you are done. That's the derivative. That's as hard as they're going to get. There's nothing that's going to be harder than that. That's 4 layers deep. That's as rarely will you see a 4 layer. On the test, when we do take eventually a test or a quiz on this, most of them will be 2 layers or 3 layers. Okay? They won't be 4 layers deep. The one that we're going to do next from 3B is only 2 layers, is 3 layers deep. Okay? So that's the one we're going to do next. All right. So the first thing I'm going to do is rewrite it. Rewrite it without the roots, without the fractions, all that stuff, like I did earlier, like we did yesterday. So we said g of x. We said tangent 4x squared plus 1 to the negative 1/2 power. That's how we rewrote it.
The negative 1/2 that's on the bottom.
Mm-hmm. Yeah, because the root's on the bottom, it's negative 1/2. Yeah. If it was the root on top, it would be positive 1/2. Yeah, so the root this time is it's over tangent and the angle. It's not just, like the last one was just the angle. This is the whole thing. So that's why I have to put everything to the negative 1/2 power. Okay? And then we said our outside layer was 3 times something to the negative 1/2 power. So that's what I'm going to do.
Thank you.
Okay. So if I have 3x to the negative 1/2, because this is the same problem, in your head you should be thinking, I'm doing that. Because that's all you're doing. 3 times something, right? Don't worry about the tangent part yet. We're not there yet. If you have 3x to the negative 1/2, you would move the negative 1, multiply, and subtract a power, right? That's what you would do. That's exactly what we're going to do. Don't worry about the inside stuff. We'll get to that later. So it would be negative 1/2 times 3. And then I would subtract a whole power. So if I subtract a whole power from negative 1/2, what do I get?
Negative 3/2.
Negative 3 over 2. Okay, that's the derivative of the outside. Now I'm going to just rewrite the inside. Okay. The second part, right? The next part was this guy, tangent, right? That was tangent of something. Tangent of something, right? Picture it's just tangent of x. What would the derivative of tangent of x be? If you don't know, look on your sheet. Secant squared. So it's going to be secant squared of something. What is that something? Everything I haven't touched yet, which is the 4x plus 1. You can write secant squared like that, or you can write it like that. Either one's okay, because it means the same thing. Okay, one more chain, one more link. So now the last thing is the very, very inside, right? We said the inside was 4x squared plus 1, and the derivative of that is just 8x, right? Done. Now we just got to clean it up a little bit. So we have this guy times this guy times this guy.
So we got 8x times 1/2.
So it's going to be negative 12x, because 3 times 8x is 24x, and then times negative 1/2 divided by 2, you get negative 12x.
Why do you multiply them together if they're not like common terms?
So they're monomials. Because it's a multiplication problem, because this is this, it really is this times this times this. We can multiply it. If that was a plus here, you couldn't do it. If that was a minus here or a plus here, you couldn't do it. But because it's multiplying. And then we have, okay, so I'm going to start to give it back some of its powers. I can see that the tangent has a negative 1/2 or negative 3/2 with it, right? So that means it's going to go down to the bottom. So let me write a. Secant squared doesn't. So secant squared is going to stay on top. Square root. Oh, sorry, the square root of tangent.
Supposed to be negative 12x?
Yeah, sorry, I forgot the x, yeah. Let's see, 4x squared plus 1, and then this stuff on the inside is to the third power. Because that's what the 3 means. The 3 means cubed, the bottom means square root. And you're done. Okay. So the last part of the notes is combining some of the properties, or some of the rules, right? We have power rule, we've used that a lot. We have product rule, we haven't really used product rule at all in this set of notes. We have quotient rule, which we haven't really used, and we have chain rule, which we've used a lot in these notes, obviously, because they're the chain rule notes. So what we're going to do is we're going to mix up some of the rules, or not mix them up, but combine them. So sometimes you got to combine rules. So we got to find the derivative of this guy. So before I make any decisions,
Oh, you have to get rid of the root.
get rid of the root, right? Get rid of the root. So let's rewrite this. The first guy is a binomial x squared plus 1. Doesn't need to change. The second guy is a root, so I need to make that 2x minus 3, right? And this is going to get a 1/2 power. Okay. Now, how am I going to find derivative of these two guys?
Using the
Product rule, yeah. Product rule because, why product rule? Because you have this guy times this guy, right? If you have two things times each other, that's the product rule. So I'm going to use the product rule. Okay, so the product rule says the first one repeats. So what's the first one? X squared plus 1. So x squared, and since it's a binomial, I'm just going to keep the parentheses around there. Times the derivative of the second one.
Is that where you use the chain?
This is where I'm going to have to use the chain rule, yeah. The derivative of this guy. This guy, it's got layers to it. The first layer is something to the 1/2 power. The second layer is 2x minus 3. So if I want to find derivative of the second guy, I need to use the chain rule. So that's going to be 1/2 in the front. Subtract a power. Chain. Derivative of the yellow. 2 plus. Okay. Now the opposite. The second one, just rewrite it. So I'm going to rewrite the second one. Times the derivative of the first one. What is the derivative of the first guy? 2x. 2x. You just use the power rule. You don't need the chain rule for this guy because there's no power. There's no power. It's just the power of 1 out here. You don't need to use the chain rule for that guy. We had to use the chain rule for the other one because it had a power of 1/2. Okay, calculus is done. Now I have a plus in the middle. So I'm still going to have a plus there. So on either side of the plus, I need to do what I did last time. So I'm going to multiply this guy and this guy. 1/2 times 2 is just 1. Right?
So
Just
it'd be
positive
x
1.
squared times 2x.
So it would just be binomial x squared plus 1.
Over.
And then over, yeah. So yeah, I'll do that later. But yeah, it's going to be over that because it's got a negative power, right? The other guy, the other side, it's really one big binomial. I can't multiply, I can't distribute this 2 because of the power, the 2x because of the power. So I'm just going to write 2x minus 3 to the 1/2. Last step, negative exponents, give them back powers if they need them. So this guy's, since it's on top, it's going to move to the bottom. So it's going to be x squared plus 1 square root 2x minus 3 plus 2x minus 3.
Times 2x or no? Oh, wait, sorry.
2x in the front, yeah. I put a 2x in the front. Oops, and then I forgot parentheses there. That's as far as you need to go. Okay. All right. Let's try another one. Okay, so example 5 is the last one we're going to do. There's an example 6, but but I moved example 6 to another lesson because it fits better in the other lesson that I'm going to do later. So
Just cross it.
yeah, cross it out. Cross out example 6. Example 6, cross it out. It's definitely important, but I think it fits better in a later unit, a later lesson, so we'll do that separately. Okay. Okay, so a couple things. First thing, we're going to do the last one together, 5B, and then I'm going to give you a few practice problems to do on your own. Okay, and then tomorrow we'll do the practice. We'll do the independent practice. Okay? So this is not the last one we'll do together. I'm going to give you a couple more problems to try on your own. Okay? Okay. This guy here. Before I find derivative, do I need to rewrite it at all? Do I need to take out things, or can I rewrite it? Do I need to rewrite it?
You gotta not make it a fraction.
So you'd want to do that. You can do that, but I would suggest not. I would suggest leaving it alone. If it had a root, I would maybe do that, but because this is a binomial, I'm going to leave it the way it is. I could move this guy up, but because of this power, it's going to complicate things a little bit. So this one's okay. This one I can do. Okay? This one I don't need to change at all. So I can go into now finding a derivative. Okay. Which rule do I start with? Where do I start? Where do I start?
The chain one.
So I'm going to start with the chain rule. Yeah, a lot of students look in the inside and they're quotient rule. Yeah, we'll use quotient rule. Don't worry, we'll get there. But we're not there yet. Okay? The first thing I want you to notice is the outside layer. This is the outside layer. The fraction on the inside, the rational expression on the inside, that's the inside layer. So I'm going to find the derivative of the green first, and then I'll find the derivative of the yellow. That'll be my chain. So this has got two levels. So the first thing is something to the 9th power. Something to the 9th power. Move the 9 to the front, subtract a power. The yellow stays the same. Good. Okay. Chain. So I found the derivative of the green. Didn't change anything with the yellow. Now we'll go to the yellow. Now to find the derivative of the yellow, what am I going to use? Quotient rule. So low, 2t plus 1, times the derivative of the high. The derivative of the high, what's the derivative of t minus 2? It's just 1, yeah. Minus the high times the derivative of the low. What's the derivative of the low going to be? Just 2, yeah. Over the low squared. So calculus is done. So we're done with the calculus because I found the derivative of everything. Had 2 layers, and I found the derivative of both. Now what I have to do is kind of simplify it, get rid of parentheses as much as I can. So watch, this one's a little different. Actually, it's not that different. So I'm going to distribute the 1 here. I'm going to distribute the 2 here. That's the first thing I'm going to do. Times, okay. So I get 2t plus 1 minus 2t minus 4. Okay. Now I'm going to distribute the negative to both, or just subtract them. That's another way of doing it. So I get 2t plus 1 minus 2t plus 4. Two t's cancel out. Combine like terms, and you get positive 5 on top. So we get 9. Okay. So I can actually simplify this a little more. The reason I can simplify it is because I have common denominators. I know I'm multiplying, you don't need common denominators, but I do, so I can combine some things. So watch what I do. I'm going to combine them. Oops. So I'm going to rewrite the fraction here. They both get an eighth power. The top gets an eighth power, the bottom gets an eighth power. That's when you give a fraction a power, it means the top gets that power and the bottom gets that power. Okay? So the top is t minus 2, that's going to get an 8. And the bottom is 2t plus 1, that's going to get an 8. Okay. Now I'm going to multiply straight across. When you're multiplying fractions, because it's really 9 times a fraction, right? When you're multiplying straight across, you just multiply. So I'm going to multiply 9 times 5, since they're both in the denominator.
45.
I get 45. And then I get t minus 2 to the 8th power. The bottom, I have 1, you don't need to write that. And then I have these two guys. What do you notice about these two guys?
They're the same.
Base, we call it a base, right? They're the same base. What do I do with their exponents if they have the same base? Add them together. So we get 10th power. And there you go. That's as far as you go. Okay. All right. Okay, so the last thing we're going to do is I'm going to give you at least 2, maybe 3 problems. I want you to practice them. They're practice right now. Right now you don't got to worry about it because it's just practice, right? You want to try to get them right, but if you don't, it's not that big of a deal. Okay? All right, so find some room on there, probably around where we crossed out the other ones. Okay? So let me see. We'll call this one 5C. 5C. So we got x over find the derivative. There's the first one. And then the second one was 5C. 5D Okay, do those two. Same thing, find y prime. All right. Okay, so 5C you could do one of two ways. Right? 5C you can rewrite it like I did on top, or you can rewrite it like I did on bottom.
What are the inners then?
One's not more right than the other. They're both possibilities. The only difference is if I was going to do the top, then I would use my next step would be to use the product rule. If I'm going to use the bottom, my next step would be to use the quotient rule. They both function the same. Okay? JJ, you got all this written down? You had the notes yesterday. Did you lose them? The same exact notes. Okay? So it doesn't really matter. So you could use the top, you can use the bottom. It's not a